0.903. So that would be joule per gram per degree centigrade times T of funnel minus T of aluminum is 45.8. Equal to the mass of aluminum is 105.3 gram times, and then for water specific capacity is 4.18 joule per gram per degree centigrade time TF going to be same for all, and T of water is 15.4. So out of 7 values, out of 7 we have 6 is given. So your chemistry problem is same. Plug in whatever you have, find out what you don't have. So look at the only TF is the one missing, right? The TF. Everything else is given, right? Okay. And then calculate by your own. Okay? Do that.
Can you do only one side?
Yes, you can. What do you do? The easiest way. Let's go. Easiest way is multiply outer side, out of the bracket, right? Multiply this side, right? The one is smaller. Divide both sides by smaller value.
No, what I mean is,
Yes.
we don't need. I just want to get the capacity of metal, and I'll work on that by itself, and I'll get the temperature the final temperature.
Do that. Multiple way you can do that, right? Many way you can do it, yeah. But I'm saying easiest way, dividing, multiply this part, divide by smaller one. You can follow your way through, yes. Okay? So you have the solution here. This is the way you can do that, multiply both sides and then make it divided, okay? So I have 2 more problems for you. This is another one, similar. You can do by your own, okay? Solve them, and next class is going to be the review. We'll be going over these problems again. So I just gave you the hints, solve it out, and then we're going to go over them on next class. Okay? Let's go. Following topic of this chapter is Hess's law. What does Hess's law mean? What is this law for? This law is showing that the amount of enthalpy for a reaction is same whether you go direct reaction or you calculate their each step. Because in chemical reaction, you see some reaction reactant to product, but you don't see there are multiple steps going on between reactant and product. So this one, for instance, coming on reactant for only one step. Actually, it came through a lot of intermediate. We don't show that in here. And now question is, what do you need that for? Why do you need to calculate the total enthalpy? For instance, in laboratory, you do a chemical reaction. So you need to see how much heat that will be producing. Is it exothermic or endothermic? You can determine before starting your reaction. So let's go. This is like graphical way of showing your Hess's law. Let me give you a more practical example. Remember in last class we talked about that, me, Josh, and maybe David. So me, Josh, and David planning to drive to NASA, right? So 3 people following 3 different GPS. One say, oh, I like Google Map. Some say I like iPhone Map. Sometimes say, I'm gonna follow my crazy Samsung map. Okay, I'm just making it up. Maybe Samsung map is better than others, okay? Maybe, I don't know. I don't use Samsung at all. So I use fresh iPhone, you see? Anyway. Purely iPhone, that's okay?
Yeah.
And there are some fake iPhone by the way. Yes, I bought that. I got cheaper than I bought it. Yes, that's fake. Yeah, I bought from Amazon, maybe $200, and then I see it's fake. It's not original.
Did it work though?
No, it didn't. It go in for a month. Anyway, let's go back to our profile. Yes. So me, Josh, and David is planning to drive to NASA, right? So 3 different GPS taking us 3 different ways. But we ended up into NASA. When we ended up NASA, then we all 3 met together, and then we say, okay, what's happened? Why did you go to all the way west, Hillcroft? Why did you go to the, Beltway 8 west? Because GPS took you, right? So that happened, by the way, guys. So however which path you follow, which way you follow, it doesn't matter. You go into NASA, we are going to be hitting NASA at a certain point. So any route you follow, you ended up driving 50 miles from here to study NASA. You cannot claim that, oh, I came 200 miles. Doesn't matter, why did you go there, right? It's a 50-mile path. That's the way you travel. So this is something kind of here. So this is reactant and this is product. We are here, we are going to NASA, right? And of course, we need to follow a certain route. So in this route, when you go there, and then when you go there, like me, Josh, and David started going here and here, and then finally we hit in here. Wherever you go, going, finally we hit up here, right? So actually, at the ended up, we found that we went only 50 miles. That's the difference between from here to NASA. That's actually we traveled. No matter how did you go, we ended up from here. And we have to count how much energy difference is from reactant and product. I'm trying to go back to analogy to the reaction. So however you go, we travel this amount of distance. If you take the analogy to the reaction, however you go, how many steps you follow, does not matter. You ended up going this amount of potential energy. Suppose that is 10 kilojoule. That's all we got. So this is, if this is delta H3, and sorry I messed it up, right? So this is the delta H1, and this is again delta H2. So delta H3 equal to delta H1 plus delta H2. Wherever you go, actually you travel this distance. So let's see some practical example, then you can see what's going on. This is the reaction actually, carbon and hydrogen burning, and then it forming, this compound name is propane, is forming propane. To make this, actually 3 intermediate reactions was going on. 1, 2, 3. So from these 3 reactions, we have to be able to calculate this one. How can you do that? The way it does that, so our goal is to manipulate these intermediate reactions and then reach out to here. And how do you manipulate? We manipulate as whether you can reverse it, we can multiply it, we can, and then ended up we sum it up. Let's go the rules first. Keep in your mind how the example look like, okay? That will be easier to understand the steps we follow. So, rule number 1 is you must follow all reactions. I mean all intermediate reactions you follow to calculate final reaction. And second thing is, when reaction multiplied by a factor, it multiplied, and delta H also multiplied by a factor. So let me take that off, that would be easy. So the reason is multiply by a factor, you also multiply the whole thing. Why is that? For instance, you have carbon plus oxygen. There is a question, is it important to write state? Yes, it is in this case, because you need to cancel out something. So carbon dioxide, and which is delta H equal to negative 393.5 kilojoule. So this is the exothermic reaction, and as you can see, it is producing the heat. So first rule is you must use all reactions. You have to manipulate all of them to get final product. Second rule is when you multiply by a factor, you multiply also with enthalpy. What does it mean? Look at that. To get this reactant and product, right? How you manipulate? Look at that. What you have in this? You have 3 carbon. And look at where you have carbon in these 3 intermediates. First one, second one, third one. Which one you have carbon? Do you find carbon in the 1, 2, 3 reaction? You don't find carbon nowhere?
Is the first one? Where is that first?
Second reaction. But you should be quicker. So second one you have a carbon, right? But you have 1 carbon, you have 3 carbon. You need 3 carbon, which is your final reaction. So you have to look at the coefficient. The coefficient is 3, so you need 3. So that means you need to multiply this equation by 3. Multiply by 3. So 3C, when you multiply 1, the rule is saying that when you multiply any of them, you multiply all of them. You also multiply to the enthalpy as well. So look at that. So you're multiplying this, multiplying also this, also you're multiplying this by 3. Then if you multiply 3, then you have left hand side have carbon, you also get left hand side carbon from this second equation. And then what else you need? You need hydrogen, right? Which one has hydrogen? Third one. Is it coefficient same? No. So to get 4, what do you need to do? Multiply by 2. Let's do that. So multiply by 2, so equation 2, equation 3, multiply by 2, right? Then get 4 hydrogen gas plus 2 oxygen, also gas, which is forming 4 water, which is also gas, right? And then also multiply with its enthalpy. What is enthalpy for third reaction? Is it third reaction? Yes. The third reaction enthalpy is delta H equal to negative 483 times 6 kilojoule times 2. Then what? What else you need? The product. In the product side, you need this compound called propane. How can you get propane in the right hand side? If this reaction you flip it, you swap this reactant with the product. How about that? Yes. If you swap it, then propane is going to be the right side. Oxygen is going to be right side. Carbon dioxide will come as a reactant left side. Water will come on the left side. So that's the called third rule. Third rule is if you reverse or swap the reactant and product, then the sign of delta H will be changed. Right? So you need to swap or switch the product to reactant, reaction to product. So number one, what do you do? Coefficient is same, so you do not need to multiply. You see? So just keep writing 3 carbon dioxide plus 4 water. This was the product, now you're writing as a reactant. And then the reactant you have C3H8, which is gas, plus 5O2, you're writing as a product. And delta H you have in the negative, you reverse it up. Since you flip reactant to product, you reverse it up with a positive plus 2043 kilojoule. Now you add it up, add all three. You have 3 carbon dioxide, right? 3 carbon dioxide. You have 4 water plus 4 water, right? What else you have? You have 3 carbon and so plus 3 carbon and carbon you have solid plus oxygen. Look at that, you have 5 oxygen. So total 3 plus 2. You're adding up 5 oxygen. Also gas. Then what? You have hydrogen. How many hydrogen you have? You have 4 hydrogen. Then in the right hand side. So you added all of them up, carbon dioxide, water, carbon, 3 carbon, 3 oxygen, 2 oxygen, 4, 5 oxygen, and 4 hydrogen. You see? You wrote down all of them. Yes?
So you don't pay attention to the subscripts?
You do.
You just add up the
Yeah,
coefficients?
Yeah, I looked at it. That's why 2 and 3 become 5.
Yeah, I'm talking about the subscript, like the small.
That's called subscript. Oh, subscript.
Yeah.
You do. You focus on that. Yeah. Look, I carbon dioxide with 2. H2O, I put it 2.
Yeah, but okay, so they just stay the same. You don't change.
No, I don't change it. And the right side, what do you have right side? Right side you have C3H8 in gas, plus you have 3 carbon dioxide, plus you have 4 water. You see? And plus you write enthalpy. When you write enthalpy, this is going to be the 1, but the other 3 you need to, this one you multiplying by 3, this one you multiplying by 2. Right? Yes.
There's also a 502 up there.
What is that?
For the oxygen.
Oh, there is 502, right? So if you multiply this with the 3, then you got negative 1181 kilojoule. Then this one with a forming water, you got 967 negative 967.2 kilojoule. So now you add this up, you're adding this with this and subtracting from this. Because these 2 are negative, this is the positive. So finally you got, if you add them up, you got negative 105 kilojoule. That's what you got final enthalpy. So enthalpy of this reaction, that's what you got. And then you see something, left side have 3 carbon dioxide, which also have right side. Then you cancel them out. And then you see 5 oxygen, right side, you see 5 oxygen, also left side. Then you see water, 4 water, also 4 water, right? So then you left with 3 carbon, solid, plus 4 hydrogen, gas, which is forming. Everything cancel out, you have only propane, C3, H8 propane gas. You see?
That is so
Yes.
much work.
So much work, yes. You have to play with all three. Remember the formula was you must use all reactions.
It's easy.
All reactions you play to get the final reaction. That's the final ultimate goal. That's your model. That's what you gotta make yourself up to look like this model. You don't change your model. You change yourself to get to look like a model, right? So you modify your reactions, all of them, to get your ultimate reaction. And enthalpy will be changing accordingly, right? So I have 3 more reactions for you. Solve them up at home, and then come up to the next class. We'll be working together. Yes.
So the last problem, since it's on the test, are we given the first,
That's what exactly you'll be given.
so, okay, so then to find,
This ultimate reaction.
well then, okay.
All of them will have enthalpy. You manipulate them as needed, following those 3 rules, and make up the final reaction.
So do we have to even write it all out, because with the rules we know if it's positive or negative?
Yes.
So you still want to see us write it all out?
Yes.
Okay.
If you write that out, otherwise you cannot solve it.
Well, I mean, on the, do we actually have to do the left-hand side, because all we have to do was find that it was negative 105 kilojoules.
Oh, for
Yes.
instance.
Yeah.
Yes, you have to write it.
Just want us
You have to write it out.
step
You have to write it
by
out all the steps
Okay.
to really solve it and cancel out that
This
you don't need. Then, because if you don't cancel out and multiply that, it's not possible to get your final
Because you
reaction.
still need coefficients from there to times the FOB over
Yes.
there.
Okay.
Like for instance, let's go this one. This one you have 3 hydrogen, right? You need to modify this guy. 2 hydrogen. How 2 become 3? Tell me. Times 3/2. So 3/2 make it to the 3, right? Second one is you have 1 of ozone, you have 2 ozone, right? You multiply by 2 and flip it. Then you get 2. And water, you have right side already have it. Simple, right? I know. Okay? Next class will be solving the other problems, and then get ready for that. Do practice at home. Thank you.